Hi everybody, I'm going to put together a video here for sketching the tangent function. I've got myself set up here with my first question, which is to sketch y equals minus 3 tan 4x over the domain negative pi to pi. You can see on the right hand side of my screen I've set myself up with some important things that might help me, which is the base graph of tan, the unit circle and the exact values table. I'm going to talk about the question and talk through a few parts here. If I was doing this in an exam question, I would go a little bit quicker and I probably wouldn't write down all of these things. I'd just be doing it in my head or just thinking about it in my head as I go along. So when I approach this question, the first thing I do is a little quick analysis of what's going in my problem. And the first thing I spot here is a negative out the front, and I know that this creates a reflection in the x-axis. So at some point my base graph's going to be flipped across the x-axis. I know that the 3 there is a dilation from the x-axis by a factor of 3. So in a tan graph, a dilation from the x-axis doesn't change a whole lot. It does stretch the graph out, but it doesn't change the range because the range is R for all tan graphs. But the big one here is probably the 4 inside the bracket here. So I know that that 4 creates a dilation from the y-axis. And it's going to create a dilation by a factor of 1/4. Remember, it's always the reciprocal of that value, so it's 1 over 4. So this dilation from the y-axis is going to change the period of my graph. So let's go ahead now and start thinking about how we're going to sketch this and get a few extra key pieces of information. So the first thing I do with the tan graph is I find the period. And the rule for finding the period of a tan graph is pi divided by n, and in this case my n value is 4. So that's really useful. Because it's a tan graph, we don't worry about the amplitude. That's specifically for sine and cosine. But what I do need for the tan graph is I'm going to find out where my first asymptote is. And my first asymptote can be found using the rule pi divided by 2n. So in this case, pi divided by 2 times 4, which is pi divided by 8. Now when we did the sine and cosine graphs, I showed you my hack for finding the scale to help you draw your graphs, and we multiplied the period by 1/4. We're not going to do that for a tan graph. We're actually going to use the first asymptote as the scale for my graph. So let's start setting up my axes and start setting up my graph here. Actually, we need to go from negative pi to pi, so I need a left-hand side on my graph. I'm just going to make this a little bit wider so I get multiple parts. Okay, so my first one, pi on 8, then 2 pi on 8, 3 pi on 8, 4 pi on 8, so on and so forth until we get all the way up to 8 pi on 8. Why did I need 8 pi on 8? Because my domain had to be between negative pi and pi. So 5, 6 pi on 8, 7 pi on 8, 8 pi on 8. I know those numbers might be a bit hard to read, but I'm sure you'll work it out. Same thing in the opposite direction. Negative pi on 8, negative 2 pi on 8, negative 3 pi on 8, negative 4 pi on 8, negative 5, negative 6, negative 7, negative 8. Just filling in the numbers here. Sorry, it's a little bit slow and a little bit hard to read. Okay, so my tan graph has an asymptote at pi on 8. So that's going to be here. There's my first asymptote. And then when I work around my circle, so here's my unit circle. As I go round the unit circle, normally I'd get to pi on 2 before I have my first asymptote. And at pi on 2 then my tan graph is immediately negative after that as I go around to pi. And then tan goes back to 0 at pi. And then tan becomes positive again in the third quadrant as we move around before I get my second asymptote. So what that's going to do for my graph here, with my intervals that I've created, I'm going to have 1, 2 intervals before my next asymptote, because I had 1 2/4 of the circle before each asymptote. So we go around 2 parts of the circle, then we're going to get an asymptote. 2 parts of the circle, then we're going to get an asymptote. So my asymptotes are going to be every 2 scale factors, or my asymptotes are going to be the first asymptote plus the period. Okay, but I can just use my scale to put all of these asymptotes on there directly. So they will just be 2 points apart. No fancy maths, just put them on. Right, I'll rub off those 2 little arrows so they don't confuse you. So now I know where my asymptotes are. I can just start sketching my tan graph. Now normally I would be starting at 0 and going up to the asymptote, and then I would go from the bottom up to the midpoint, and my scale's already created all of those x-axis intercepts, and I would just keep going and I would repeat. But this is where my analysis at the start comes in, because we found out that there was a reflection in the x-axis. So I need to incorporate that reflection into my graph. So normally I would be going like this, but instead in this case I need to actually do the opposite. So my tan graph is going to go down in that first part, and then it picks up at the top, get my x-axis intercept at 2 pi on 8, and then it continues down again, and then we just repeat our graph. And because my scale is set up for me, all of my x-axis intercepts are already defined, and I just get this beautiful tan graph where we have to keep the flow going. A couple of key points when we're drawing out tan graphs: do not have your line touch the asymptote or you lose a mark. You must always label endpoints. So I'm running out of space on the side of my page here. That's minus pi 0. This endpoint is pi 0. We should always label all of our asymptotes with a rule. So we'd go along and put all of those asymptotes on there. Now, if this was an exam question, they wouldn't make you repeat this so often. They'd have the questions set up so there wasn't so many to do. But we're just going to go along and do that here for this, because if you see me do it 10 times, you might remember that you've got to label your asymptotes with a rule. 3 pi on 8 minus 5 pi on 8. Got to have the x equals, and then x equals minus 7 pi on 8. And then finally, we need to have all of our intercepts with their coordinates. So 0, 0, pi on 4, 0, 2 pi on 4, that's a bit silly. We can go a bit smaller than that. 2 pi on 4 is pi on 2, pi on 2, 0, and 3 pi on 4, 0. So we label all of our coordinates, or our intercepts. We label our endpoints, we label our asymptotes. And that was a bit of a repetitive graph, but hopefully seeing that repeated lots of times, you'll remember some of those key things. Okay, didn't need to use my exact values table because I didn't have to do any solving. The axes intercepts were all found just using that scale. So let's have a look at an example where it's not quite so straightforward and there's some translations that move it around a little bit. Okay, my second example, we're going to sketch y equals 1 plus tan 2x over the domain negative pi to pi. So same domain again. All right, now start with the same thing. Quick analysis of my graph. What's going on here? This 1, I can get a little bit confused about what that does to the graph. If it helps you, you can rewrite your equation as tan 2x plus 1. They're the same thing. So I know that that one there is a translation up 1 unit parallel to the x-axis. Sorry, parallel to the y-axis. Now I've been writing that out the long way because we didn't do a great job on that in our last test in writing those transformations properly. This 2 in here, that's a dilation from the y-axis by a factor of 1 over 2. So that 1 over 2, that's going to change my period. So let's go ahead now and let's find the period. We know that the period of my tan graphs is pi divided by n, and in this case n is 2, so my period is pi on 2. And my first asymptote is at pi divided by 2n, so pi divided by 2 times 2, which is pi divided by 4. And we're going to use this first asymptote to work out my scale factor for my graph. I haven't got any reflections, I haven't got dilations away from x, so I've got most of the key pieces of information to help me draw my graph. So what does it look like? Well, let's start with drawing our axes. I need to give myself a bit more space. I did the same thing again, I made it too small. Let's go right down here. Give myself heaps of space this time. I felt a bit squashed on the last one. Okay, now my first asymptote is at pi on 4, and I'm going to use those pi on 4s for my scale. 2 pi on 4, 3 pi on 4, 4 pi on 4, which is equal to pi. Same the other direction, minus pi on 4, minus 2 pi on 4, minus 3 pi on 4, minus 4 pi on 4. Okay, first asymptote. Now I'm going to do an extra thing here. My whole graph has been shifted up one place. So to help me with my sketching, I'm going to just draw a little line at y equals 1. So I've drawn a line at y equals 1 just to help me sketch that transformation. I really shouldn't put an equation on it because it's not an asymptote, and if I've gotten an equation, an assessor might think that it's an asymptote and dock you a mark. But I'm just using this line here at 1 to help me sketch the graph. What I am going to put on is my asymptotes, and my first asymptote is at pi on 4, and then I just go across 2 of my scale factors, which is actually equal to the period, to get my second asymptote. So that's at x equals 3 pi on 4, and I don't need those little arrows, so I'll rub them out again. Next asymptote, x at minus pi on 4. Remember, we've got to label all of these asymptotes with their equations. Exam questions always say label asymptotes with their equation, or it's implied. Okay, then it's a normal tan graph. It hasn't been reflected, so I'm going to start at this point 1 because it was moved up 1, and I'm going to draw my tan graph going up from there. And then from the bottom up again to my line 1, and then up to my next asymptote. Up to my line 1, and we keep the graph going. And I use that line to find the midpoint, or sort of that point of inflection of the tan graph. Good question. Is it called a point of inflection? I'm not 100% sure, actually. That would be something I'd have to double check. Okay, label my endpoints. This is at pi and 1, and this one's at negative pi. Oh, I don't need a fraction there. 1. Okay, we've got my endpoints. I have my y-axis coordinate, and I have my asymptotes. All I need to do now is I need to find all of these x-axis intercepts. So we've got a bit of extra work to do before we finish our graph here by finding these x-axis intercepts. All right, x-axis intercepts. We know that the x-intercepts occur when y equals 0. So now we've got to go through that whole solving equations thing. 1 plus tan 2x. Okay, so first step, we start solving the equation. So I'm going to move the minus 1 to the other side, and we get it down to where we just have sine, cos, or tan by itself. So we've done the first step. Now we ignore the 2, we ignore the minus, we just look at the tan and the 1, and we find our reference angle. And we want to find out our reference angle, which is when tan is equal to 1. So we go up to our exact values table here, and we've got tan is equal to 1 at pi on 4. So my reference angle is pi on 4. So we're looking for answers that have something to do with pi on 4. Cool. So now we go up to our unit circle, and we say, well, when is tan minus 1? Well, tan is minus 1 in the in the second quadrant and in the fourth quadrant. So these are the 2 points when tan is equal to minus 1. And you might remember my acronym, all students talk crap. So tan is positive in here because they're all positive. Tan is positive in here in the third quadrant because that's what the T stands for. So tan is negative in the second quadrant and negative in the fourth quadrant. Okay, so we've got our 2 quadrants. We know they've got something to do with pi on 4. So I can actually start working these out. This angle will be equal to 3 pi on 4. And this angle here, all the way around to this point, that will be 7 pi on 4. Sorry, had to think about that. 7 pi on 4. Okay, so I've got my reference angle. I then find my first 2 solutions, and my first 2 solutions for theta, and now remember theta isn't just theta here, theta is 2x. So my first answers for 2x are equal to 3 pi on 4 and 7 pi on 4. So let's go ahead and find out what x has to be. X has to be 3 pi on 8 and 7 pi on 8. All right, we've got our first 2 solutions, so we can work this out pretty quickly. That this one here, right here, will be 3 pi on 8, 0, which means that this one here has to be 7 pi on 8, 0. So we've got our first 2 x-axis intercepts. Now we've got to find our 2 going the other direction. And remember, our axes intercepts, all I have to do to find them is I have to subtract the period. So let's start by subtracting the period. Here's where I had my first hack. If we work out the period, and let's get the period to have the same domain as my solutions. So currently the period is equal to pi on 2. I know that pi on 2 is the same as 4 pi on 8. So what I need to do is I need to take my solutions down here. So take these two solutions and I'm going to subtract the periods until I get all of my answers. So my next, messing up my colours here, my next x-axis intercept will be at 3 pi on 8 minus 4 pi on 8, which is minus pi on 8. That's within my domain. That makes sense on my graph here. This one is minus pi on 8, 0. We've got that x-axis intercept. Now to get back to this next one, I have to take my minus pi on 8 and subtract the period again. So to get my last solution, I don't know why I called that one 1, that would have been solution 3 and this one's solution 4. To get my last solution, I want minus pi on 8, subtract that period again, 4 pi on 8, which is minus 5 pi on 8. Have a look at your graph, that minus 5 pi on 8 makes sense for this point. So it's minus 5 pi on 8, 0. I've got my x-axis labelled, I've got my y-axis labelled, I've got my asymptotes labelled, and I've drawn my tan graph. That is now complete, absolutely perfect, 100% correct. Fair bit in that, folks. We do need to practice and keep practicing those solving skills as well as those transformation skills. Hopefully that makes sense.